All right, our last section of Unit 4 continues with triangle congruence, but now we reference that the corresponding parts of congruent triangles are congruent. So let's go ahead and list that out. CPCTC stands for corresponding parts of congruent triangles are congruent, which simply states that if you can prove a triangle is congruent using, let's list them all out, side, 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 angle, side, angle, side, angle, 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 side, or hypotenuse leg theorem, any one of those five, if we can prove two triangles are congruent, then all of their corresponding parts are congruent, okay? It can be used as a reason or justification in a proof after you have proven that two triangles are congruent, using one of those five congruence postulates or theorems up above. Okay, so let's take a look at example A here together. Example A states that a landscape architect sets up the triangle shown in the figure to find the distance, JK, across the pond. This distance right here. What is the distance? Well, if we have two triangles here and we can identify them as congruent, then we might be able to use this length down here to help us find the length of JK. Well, we definitely have two congruent lengths, or a pair of congruent lengths. Here is another pair, and then hopefully we can notice that we have vertical angles in the middle, opposite sides formed by two intersecting lines. So these two triangles are congruent by side angle side, which means every single part is the same. So MN would be the same length as JK. JK would also have a length of 41 feet. Okay. Why don't you try B? First, you need to make sure those two triangles are congruent before you find the length of AB. This length right here, the length across the river. Okay, go ahead and try B. Well, we have a pair of 90-degree angles, and we have a pair of congruent sides. We also have vertical angles here as well. So these two triangles were congruent by angle, side, angle, right? Here's your angle, here's the side, and then the angle. So the side is included in those two angles. So that means the two triangles are congruent. So if the length across was 500 and DE we are told is 420 feet, then AB would also need to be 420 feet because the two triangles are congruent. All right, we're going to take this a step further and try some proofs here. We're going to do example A together. We're proving that a corresponding part is congruent in the triangle, but we need to first prove the two triangles are congruent. Let's always start with our givens. X is the midpoint of ST, and RX is perpendicular to ST. Okay, those two givens are actually going to give us a pair of congruent corresponding parts here. If X is the midpoint of ST, then SX and XT would need to be congruent because that is our definition of a midpoint, splitting a segment in half into two equal lengths. Great. And then if RX is perpendicular to ST, we're going to have two 90-degree angles here. So we could say that, and because these are 90-degree angles, they're both going to be congruent to each other. So that would be angle SXR is congruent to angle TXR because of the right angle congruence theorem. We also have a shared side, so we could state that Rx is congruent to Rx, reflexive property of congruence. And now we have enough information to state that the two triangles are congruent. So triangle SXR, make sure it's in the correct order. If you say SXR, then we would need to say TXR, triangle TXR, by side angle side. And we need one last statement in here because we're trying to prove that that one of the corresponding parts are congruent, which would be RS being the same length as RT. And because the two triangles are congruent, we can state that all of the corresponding parts are congruent, including RS being congruent to RT, because of corresponding parts of congruent triangles are congruent. CPCTC. Okay, why don't you try B? Let's list those two givens to get you going. AB is congruent to DC. I believe that's already marked on here. And angle ABC is congruent to angle DCB. Also given, let's mark that ABC. DCB, we're trying to prove that A is congruent to D. So what you want to do first is we want to prove these two triangles are congruent. The purple one and the red one. And then we can state that the corresponding part is congruent. But go ahead and prove those two triangles are congruent first using one of your congruence postulate or theorems. Finish up B on your own. Okay, you needed to use the shared side in both triangles, which was BC. So BC is congruent to itself. And anytime a length is congruent to itself, or an angle is congruent to itself, that's the reflexive property. And now we have side, angle, side information. So we can state triangle ABC is congruent to triangle DCB by side angle side. And then all the corresponding parts are congruent, which includes A being congruent to D. A is congruent to D by CPCTC. Corresponding parts of congruent triangles are congruent. Okay, there's two last proofs on here. Let's do one more together, and then you'll try B, and we'll finish up here. Keep in mind there's going to be two proofs on your final, so the more we practice, the better, and you might see some of the same exact ones that we do together on these Ed puzzles. This is given. We took care of our EG being congruent to DF right here. We also have EG being parallel to DF. That's also given. And then because they are parallel, we have alternate interior angles right here. Remember, alternate interior angles, they need to touch the parallel lines and the transversal, which they do. So we would state angle EGD is congruent to angle FDG because of the alternate interior angles theorem. And then again, we have a shared side. Using the reflexive property, we could state GD is congruent to GD. We can state the two triangles are congruent because you have side, angle, side information. So side, angle, side. Now we can state the corresponding parts are congruent, which would be the parts that we're trying to prove are congruent are EDG, this angle, and FGD, CPCTC. And now because these two angles are congruent, you could state that these two sides are parallel, and this is a great example because we have not talked about proving lines being parallel in a long time, but hopefully you remember this word, the converse of the alternate interior angles theorem. Remember from Unit 3, converse of these theorems prove that lines are parallel. If the alternate interior angles are congruent, then the lines that are being intersected are parallel. All right, last one, try B on your own. These first two are given. Go ahead and mark. Well, actually, you already have the markings up here. Add the markings as you go. You're trying to prove that AB bisects angle CAD. Using the reflexive property would be stating that this side, AB, it's congruent to itself. It's the same length on both triangles. AB is congruent to AB. Now we can state that two triangles are congruent because we have three congruent corresponding sides. So then their corresponding parts are congruent, which includes CAB being congruent to DAB. Corresponding parts of congruent triangles are congruent. And now, because these two angles are congruent, well, AB then is an angle bisector because it's splitting an angle in half. So that's our definition of an angle bisector. So after you use CPCTC, that's going to tell you more information about the figure you're working with. It might tell you that lines are parallel or sides are parallel. It might tell you that one of the sides of the triangle is an angle bisector, okay? But make sure you're proving what the problem is asking you to prove, so you might need to go a step further after CPCTC. All right, more examples in class and plenty of, I think there's a couple, 3 or 4 proofs on your final review. Remember, 2 of the 20 questions will be proofs on your final. All right, good luck, and we'll go over the final review together.